Hello, my name is Alejandro Saucedo, and today I'll be showing you how I work out the communication project. To start off, we begin with the given problem, and we write out the given formula, which in this case is the following. Once we have read the problem and written out the formula, we can determine values. We know that T ambient equals to 70 degrees as it is given in the problem, and we can also say that the initial temperature of the object is 98.6, as that is the normal body temperature. And we are also given the temperature after time, which in this case is 80 at 7:30 and 70 at 8 p.m. Once we have determined these values, we can write an equation based on the information we have so far. So we can write 80 equals 70 plus 98.6 minus 70 times negative KT. And we also have 75 equals 70 plus 98.6 minus 70 to the power of negative K. However, in this case, we add 0.5 as we know that 30 minutes have elapsed from 7:30 to 8 p.m. and 0.5 is 30 minutes in our term. So in this case, we would add that to T in this case. Now that we have those two equations, we proceed to simplify. We are given 80 equals 70 plus 98.6 minus 70 to the power of negative KT. We can add the parentheses in this case, and that would give us 28.6. However, we don't add 70 plus 28 because 28.6 is a coefficient of E. So what we do in this case is we subtract 70 from both sides. That leaves us with 10 equals 28.6. And now we want to get negative K and T by itself. So we divide by negative 28. We divide by 28.6 on both sides. That gives us 10 over 28.6 equals E to the power of negative KT. Once we are given that, we can proceed to use the natural log to cancel them out. So in this case, we have the natural log of 10 over 28.6 equals to the natural log of E to the power of negative KT. So here we can cancel out the L natural log and the E, and that leaves us with the natural log of 10 over 28.6 equals to negative KT. The natural log of 10 over 28.6 equals to negative 1.05 equals negative KT. So now we have the simplified first equation, and we proceed to simplify the second one. So we are given 75 equals 70 plus 98.6 minus 70 to the power of negative K T plus 0.5. We use similar steps to isolate the terms. So now that we have this, we would proceed to subtract 70 from both sides. That leaves us with 5 equals 28.6 to the power of negative K times T plus 0.5. From here, we divide as well. Once we are given that, we can proceed to get the natural log of both, which in this case would be the natural log of 5 over negative natural log of 5 over 28.6 equals the natural log of E to the power of negative KT times T plus 0.5. So as we did before, we cancel out the E and the natural log, and we are left with the natural log of 5 over 28.6 equals negative K times T plus 0.5. Once we have this, we can proceed to simplify, and we are left with negative 1.74 equals negative K plus T times T, plus 0.5. And now we use the substitution method. We know that the first equation simplified equal to negative 1.05 equals negative K plus negative K times T. And that is the first equation. The second one is negative 1.74 equals negative K times T plus 0.5. From here we can proceed to solve for k, as we are trying to find out t. Once we divide both sides by t, we are left with k equals 1.05 over t, which is the decay coefficient in this case. Now that we have the second equation, we can proceed to substitute k by 1.005 over t. So now we have negative 1.74 equals negative 1.05 over t times t plus 0.5. Once we have that, we can simplify. So we can proceed to divide both sides by t to isolate one. However, we are left with two t's on the bottom, and that gives us negative 1.74 equals negative 1.05 t times 0.5. And to get rid of one term, we add 1.05 to one side, and we also add it to the other side. That leaves us with negative 0.69 equals negative 1.05 t times 0.5. And we simplify more, which gives us negative 0.69 equals negative 0.525, which is given once we multiply negative 1.05 times 5. Once we have that, we can say that negative 0.69 equals to negative 0.525 over t, and we solve for t. We cross multiply in this case, and since there's no number under 69, we can say it to 1. So once we cross multiply, we are given negative 0.69 t equals negative 0.525 when we divide by get t by itself. Once we do that, we divide by negative 0.69. That gives us t equals 0.76. Now we have solved the time that has elapsed since the time of death and the time of discovery. However, we round to the nearest tenth of an hour, and that equals t equals 0.08. Once we have that information, we can go back to the information that was given to us before, and we can say that the body was found at 7:30 p.m. The time elapsed is 0.8 hours, and we can also say that that is equal to 48 minutes. 48 minutes before 7:30 is 6:42, so the time of death was 6:42.